chose 0, I chose 1, I chose 2, I chose 3, right? And then what do I get each time? Like this, well, x squared plus 2y squared equals 0 means it's 0, 0, right? So once it's a 0 height right there. And then what happened? X squared plus 2y squared equals 2. Well, you can get, what shapes are all these going to be? Do you know what shapes are going to be? Because the constant in front of the x squared and y squared are different, it's going to be a what? An ellipse, exactly. So the point is, you draw each of the ellipses, and you see how they're labeled? This is a height of 0. This is a height of 1. This is a height of 2. And you've seen topographical maps before. What does it, so you choose values that are evenly spaced, like 0, 1, 2, 3. If the contour diagram outputs for each contour are the same, are evenly spaced, what does it mean if the lines are closer together? What happens if these are closer together? What does it mean? It's steeper, exactly. Closer together means steeper. That's how you can read a topographical map. You look at it, you're like, oh, it's really dark there because all the lines are really close together. Oh, it's probably a cliff. It is a cliff, right? So you could be expected to draw a topographical map from the function. And how do you do that? You start with the function, and then you choose successive values that you think would work well. The key is pick values that are equally spaced. Pick values that are equally spaced, and then you label each of the contours. That's 0, that's 1, that's 2, and then the other one would be closer. What is this going to look like? We can get an idea of what it looks like. It's a bowl, right? It's a bowl. Exactly. Very good. Okay, so that right there, the m and n values are just two different partial derivatives. Fantastic, if I can actually get it to behave. So this right here is partial z, partial x, and that right there is partial z, partial, I know, I slip, okay? Partial z, partial x, partial z, partial y. So is the notation? Oh, writing the d's for partial? Okay, so here's the thing. What Tammy is pointing out, and it's actually a really good thing to point out from the beginning, is when there are multiple different directions you can go in, you no longer use a d. You use this right here, partial. This thing looks like a d. It's like a little swiggle instead. What this means is there are multiple directions you could go in. Multiple directions you could go in. So when this says, the way you would say this out loud is partial z, partial x, partial z, partial y. So what this means is if you find those values, you can write the equation for any plane you want. If you find these values, you can write the equation for any plane you want. Yay, very exciting. Point 1, point 2, and point 3. How many planes, how many unique planes are described by 3 points? 3 nonlinear points. Yeah, exactly. Thank you. There's only 1 plane. If you have 3 points in space, like hold up your finger in space. There's a point somewhere. Okay, 1, you hold up your finger somewhere else, like there. Okay, see those 3 points? How many, if I laid a piece of plywood down from those 3 fingers right there, you would have 1 plane. You would have 1 unique plane. So any 3 nonlinear points will define a single plane. What happens if they're in a line? What could you do with the plane? You could rotate it, right? If you have 3 points in a line, it could be rotated, and you'd have as many planes as you want. So in this case, I could ask you, find the equation of the line of the plane passing through these points, Well, you have a point. You have that equation, which is z minus z naught equals m times x minus x naught and n times y minus y naught. So you have a point. So x naught, y naught, z naught, you can use any point you want. Everybody with me so far? So what's the only thing you really need to find? You need to find m and what? N. So that's dz dx and dz dy. What does dz dx mean? What's fixed in this case? Y is fixed. That y value is fixed. dz dy, what value is fixed? The x value is fixed. The x value is fixed. So what's really nice about these right here, these points are really super nice because what do you notice? What do you see right here? The x value is fixed. So which one can you use that for? Oh, that one right there. Oh, and what do you see right here? The y values are fixed. So if you have points presented in this way, it's a lot easier. It's a lot easier. So what does that mean? You find literally the slope between. So look at this, dz dx, you have, what do you need to have fixed over there? You need y fixed, right? So you have 1 minus negative 1, 1 minus negative 1. Where's the 1 minus negative 1? And then you have 1 minus 3. So what 2 points? You go from 1 to 3. Point 1 to 3. Point 1 to 3. So you have 1 minus negative 1, and then you have 1 minus 3. Do you see the numbers up there? This is important. Do you see this? Because if you don't see it, it's really hard later. You have 1 minus negative 1 and 1 minus 3. 1 minus negative 1 and 1 minus 3. So partial z, partial x is negative 1. So where's that going to go? Right there. Same thing right here, 1 to 2. Why do we choose that? for partial z, partial y, what has to be fixed? X has to be fixed. So x is fixed right here. X is fixed right here. So we're going to go from point 1 to point 2. Point 1 to point 2. So which one is fixed there? The x is fixed. So we have, what do we have? 1 minus 3, 1 minus 3, and 0 minus negative 1. So do we have our two values here? Yeah. These are the two slopes in the proper direction. So is it really nice to get points like this?
That's really nice.
It's super nice. Like, this just becomes like an algebra 2 problem, right? Or an algebra 1. Does it change a little bit if you have 3 points that are just random 3 points? Yes, the work changes. The work changes because finding those slopes is not as trivial as this case. Not as fantastic. We have the, let's say the x values, the y values, and our output values right here. What could I ask you to do if I gave you a table like this? I could ask you, find me, if this is a plane, find me an approximate, or find me the equation for this plane. Find me the equation for this plane. Well, you can pick any point you want to be the anchor point, but then you need partial z, partial x, partial y, sorry, partial z, partial y. So if you want dz, dy, you fix x. You fix x. Like you fix x. So you look at a row, you fix x. If you want dz, dx, you fix a y, so that's a column. Just remember, I guess, if you wanted to focus on one part of the notes as the most important part right here, this right here would be the most important part. This would be the most important part because it tells you what needs to be fixed and it tells you what you need to find. Right now, it's not the algebra that's challenging in this section. What's the challenge in this section? What's the challenge about this section? Yeah. Finding the fixed value, well, picking a fixed value, but I mean in this section in terms of multivariable, as we've transitioned into 3 space, what's more challenging about this work? Yeah.
It's like visualizing.
Visualizing, right. The ideas and seeing it way more important this time around than the actual algebra, right? Will we get to mix in some nasty algebra later? Oh yeah, absolutely. Cross products, dot products, finding vector. Oh, it's gonna be so much fun. Each and every one is going to be so much fun. So another thing I could do would be find an equation for the linear function whose contour diagram. Oh, how do we know, by the way, if I look at this, how do we know that this is a plane? How do we know it's a plane? Yeah.
All of the
so when we have y fixed, that allows us to find partial z with respect to x. So what's that going to be? 0 minus 6 over, oh boy. Did I do this the right way? Did I do that the right way? No, I did it. So it's 0 minus 0. No. Oh, I got to actually do the 2, the other one. You mean not the one I circled. Good job, Josh. Sorry. So we have z is going to be 6 and 0 minus over 2 minus 0, so it's going to be 3. That better? Nice. So then you get to pick the point you want. So what's the general equation, though? Z minus what? Do you remember? Z minus z naught is equal to m times x minus x naught plus n times y minus y naught, like that? So what point do you want to use? How about 0, 0, 0? So z is equal to m. In this case, m is going to be, was it 1? So it's 1x plus 3y. Oh, the x, I flipped it. Thank you. I flipped it, yes. So it's 3x plus what? Y. Very cool. Nice. What's the quickest way to get a graph of that, given your current access to technology? Yeah.